AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Let's begin with Chapter 1, Foundations of Data Mining, Section 1-1 History of Data Mining. By the end of this unit, you should be able to outline the major milestones in the history of data mining, explain how technology has influenced its growth, define knowledge discovery in databases, or KDD, and understand its role in the field, identify key tools and platforms that helped shape modern data mining, and finally, understand how artificial intelligence and machine learning relate to data mining. Let's begin by defining what data mining actually is. Data mining is the process of discovering meaningful patterns, trends, and insights from large sets of data. A helpful analogy is mining for gold. Just as miners sift through tons of earth to find valuable nuggets, data scientists sift through raw data to uncover hidden insights that inform decisions. For example, data mining can reveal purchasing behaviors in retail or uncover hidden correlations in medical records. It's an interdisciplinary field, drawing from mathematics, statistics, computer science, artificial intelligence, and domain expertise in areas like business or healthcare. Data mining doesn't belong to just one discipline, it blends technical and practical knowledge to extract value from data. The roots of data mining trace back to the 1960s. At this point, most data management was manual, stored in paper files and physical formats. Computers were in their infancy, but their potential to automate analytical tasks started to emerge. However, analysis remained slow and labor-intensive. The idea of using machines to process data had just begun to take shape. In the 1970s, computers started playing a larger role in data management. We saw a shift from paper-based systems to digital databases. This technological shift laid the groundwork for automated analysis. Though the tools were still limited, the foundation for data mining was being built, making large-scale data processing a possibility. The 1980s marked a significant milestone, the birth of KDD, or knowledge discovery in databases. With the rise of desktop computing, researchers began focusing not just on storing data, but on finding patterns within it. While the term data mining had been used earlier by researchers like Feynman, it was within the KDD framework that data mining took on its current form, emphasizing the discovery of useful patterns from databases. By the 1990s, data mining entered the mainstream. With the explosion of desktop computers, businesses began to recognize data as a valuable asset. This was the beginning of data-driven decision-making. Capitalism played a major role. Companies wanted to use data to improve profits, forecast trends, and better understand customers. Data mining was no longer just an academic topic, it became a competitive advantage in business. The early 2000s brought the open-source revolution. The internet boom led to massive data collection. Tools like R and other open-source platforms made powerful analysis more accessible to everyone, not just large corporations. In 2003, a key textbook helped formalize the field, offering structured guidance on methods, algorithms, and practical applications. This democratization of tools and knowledge fueled rapid growth in the use of data mining across industries. As the internet matured, we saw exponential data growth, ushering in the age of big data. Big data refers to datasets that are too large or complex for traditional tools. Technologies like Apache Hadoop emerged to help organizations store and process this growing flood of information. Businesses now had access to more data than ever before, and the challenge shifted to making sense of it all. The 2010s were shaped by cloud computing and artificial intelligence. Companies moved from local servers to scalable, cloud-based storage. This allowed faster access to larger volumes of data from anywhere in the world. At the same time, social media exploded, driving demand for real-time analytics. In 2011, IBM's Watson made headlines when it beat human champions on Jeopardy, demonstrating the potential of AI powered by data mining. In 2012, Google released TensorFlow, an open-source machine learning library that quickly became a cornerstone for developers and researchers. It enabled the creation of powerful models in areas like image recognition, voice processing, and natural language understanding. Deep learning, based on multilayered neural networks, began producing breakthrough results, making data mining more accurate and intelligent. 2019 saw a major leap in natural language processing, or NLP. Advanced language models like BERT and GPT transformed how machines understand human language, capturing context, meaning, and nuance better than ever before. These breakthroughs paved the way for smart assistants, chatbots, and language interfaces, many of which you interact with today. Today, in the 2020s, data mining continues to evolve rapidly. Cloud platforms enable faster and decentralized analysis. Tools and platforms are more powerful and accessible than ever. AI and machine learning now sit on top of a foundation built by decades of data mining innovation. But with great power comes responsibility. Ethical concerns, privacy risks, and bias in data have become critical issues that data professionals must address moving forward. Remember, the book and supplemental resources are available online at Data Analytics Curriculum's website.